Okay, this is section 6.5 in your Math Links textbook, which you don't own, on division of fractions by fractions. There are two methods for calculating the quotient, which of course is the answer to a division question using fractions. You can either use the first method, which is question 7 here, using a common denominator, or, as we're going to see in about 5 minutes, using multiplication by the reciprocal. So in the first question, question 7, there's 3 questions that ask you to divide using a common denominator. So if I change this question from 3/5 divided by 9/10 to a common denominator of 10 and make equivalent fractions, then what I have here is 6/10 divided into groups of 9/10. Now the algorithm would simply be divide your numerators and divide your denominators. And when you divide 6 by 9, I'm just going to keep it like this just for a second. Because right here, if you were to divide the denominators of 10 and 10, you will always get 1 as an answer if you have common denominators. No matter what your common denominator is, you will always be dividing a number by itself, which is 1. And if I think of this in terms of my understanding of fractions, a denominator of 1 has no significance to the numerator. So because it doesn't, I can simply consider this to be simply 6 divided by 9. And then rewrite it in fraction form to get my answer. Okay? Now, of course, in lowest terms, because both are divisible by 3, I would have a final answer of 2/3. Now, really quickly, just to contextualize it just a little bit more, if I think about what this looks like, and we won't dwell too heavy on the modeling aspect of it, but if I was to have a picture, and I was to cut it into 2/10, and I was to shade in 6/10, like that. And I was to consider the significance or the purpose of this question right here, 6/10 divided into 9/10. Here's what I would like you to consider. I want you to think about, by the way, our answers was what again? Our answer was 6/9, is that right? Or 2/3, correct? Okay. If I consider this question, I have 6/10 of pizza. So I have a pizza that is cut into 6/10. But with that pizza, I have to make lunches for my kids. And every lunch has to be 9/10 of a pizza. All right? So if I think of that contextually, I have 6/10 of something. I need to divide it into groups of 9/10. Can I make a group? The answer is no. Okay? It's just like when we talked about money. But the question then becomes, how much of a group can I make? So I have 6/10. I need to make a group of 9/10. So my group has to be this big, right? My lunch serving size has to be 9/10 of a pizza. So the consideration is, how much of a group can I make? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 parts to my group, right? And I have 1, 2, 3, 4, 5, 6 parts of pizza. So the picture reflects, of my group that I need 9/10. I only have 6/9 of that group, and therefore I only have 2/3 of a lunch to make if I can cut it into thirds, right there. I only have 2/3 of a lunch I can make. So contextually, that's what it means. It's kind of a complicated thinking pattern you need to kind of make. The easiest way I always say is either think of money. I have 60 cents, I have to divide it in piles of 90 cents. That also works really well to contextualize it, or the drawing. But the truth is, if you use the common denominator method, it gets you the answer really quick. And as long as you can do that, I guess that's something. The second question gives you 1 1/2 divided by 5/6. So when you're dealing with mixed fractions, the first thing you should do is always change it to improper and rewrite the entire question. And if we're going to use this common denominator method, we're going to make 6 our common denominator. If I asked you why, of course everybody in the room would be able to tell me now because we talked about it in our warm-up. Why did we choose 6? Because it's the first multiple that 2 and 6 share. 5/6 will stay 5/6, and 9/6 will become 9/6. Divide the numerators. Divide the denominators. You're simply going to get 9 divided by 5, or 9/5 as an answer, which of course as a mixed fraction will be 1 4/5. If I drew it real quick, I don't want to draw this one because, oh, sugar. If I drew it, it would be difficult because I'd have to draw more, but I will draw it. So I have 9/6. So I have all of these sixths. And I'm going to draw it again. And I have, how many more sixths here? I have 6/6 here. And I have 3/6 here. So this picture right here is 9/6. What fraction is that also? 1.5. I have to make lunch for my kids. How big is my lunch serving? 5/6, correct? So, right there, I can make a lunch serving. I have 9/6 of pizza. My servings have to be 5/6, so I can make one. Can I make another serving? Is that enough for another serving of 5/6? How much of a serving is it? It's only 4/5 of a serving, correct? So therefore, my answer is 1 4/5. Question 3, we have two mixed fractions. So if we use improper fractions, we have 10/3 divided by 11/6. In this particular question, our common denominator will be 6. And we will have 26 divided into groups of 11/6. Divide the numerators, divide the denominators. You have 20 divided by 11, which is equal to 20 over 11, which is equal to 1 and 9/11. Question 8, which is, I think, for most of us, the preferred method of solving, the preferred method for solving these questions. It says divide using multiplication. So we learned that given all of the examples we have done, and given all the practice we did with finding common denominators, modeling, etc., we can actually take the first fraction, change the division to multiplication, and use what we call the reciprocal of the second fraction. So if I want to solve 5/12 divided into groups of 3/4, I can actually do a multiplication statement where the second fraction is flipped upside down, you called it reciprocal, and use multiplication. If I do that, I will end up with 20 over 36, which is equal to 10 over 18, which is equal to 5 over 9. Now, of course, there are a lot of intelligent people in this room, and they realize that this step that I just circled in red could have been avoided completely if they had considered what prior to doing the multiplication of numerator and denominator? Cross reduction. And the cross reduction would have happened here. What can you divide 4 and 12 by? If 4 and 12 were a fraction, you could reduce it by a factor of 4, meaning both could be divided by 4, and you would have had 1 over 3 instead of 4 over 12, which would have given your final answer 5 over 9 without having to reduce the fractions. In the second example, B, we have mixed fractions just like before. We're going to change them into improper fractions. We're going to divide using multiplication, which means I keep my first fraction, change to multiplication, and use the reciprocal of the second. Intelligent people will do what right now, Angie? Incorrect. They will now look to see if you can cross reduce. And of course, we look across here and we're like, hey, 4 over 2, that can be reduced. That can be reduced to 2 over 1. Multiply the numerators, you get 18. Multiply the denominators, you get 5. A lot of students forget that if you have an improper fraction as your answer, you should always reconstitute it back to mixed, which would be 3 and 3/5. Since 3 and 3/5, I'm just going to show you just real quick. If you had this on a test and you weren't allowed to use a fraction calculator, a regular calculator, we know as a decimal, 3 and 3/5 would be 3.6, correct? So if I wanted to check my work, and I'm like, you know what, I just want to make sure I'm doing this right, I could take my calculator and go 4.5, which is what 4.5 is, divided by 1 point what? 25. And the answer should be 3.6, correct? So therefore, I verified my answer just by translating the fractions into simple decimals. And the last question you have here is 10 divided by 2.5. Does anyone have a suggestion for an easy way to start before obviously I'm going to change this mixed fraction into 5 over 2. Does anyone have a suggestion for what I should do to 10? What would you do, Marshall Mathers? 10 over 1. Always consider to have whole numbers as over 1 because it makes your procedure for solving it much easier. Because now we're going to keep the first fraction, change to multiplication, and use the reciprocal. All right? So once we have that, we're going to then be an intelligent person and say, can I cross-reduce? The answer is yes. 10 over 5 will reduce down to 2 over 1. And when I multiply the numerators, I'll get 4. Multiply the denominators, I'll get 1, which means your final answer is 4. Verified with a calculator. 10 divided by 2.5. How many 2.5s are there in 10? Of course there's 4. Of course there's 4. Now question 9 says divide. It does not give you instruction as to whether to use common denominator or multiply by the reciprocal. So in this case, Emily, probably most people would choose to multiply by the reciprocal, but whatever path you chose or whatever method you chose is up to you. Did anyone choose common denominator? Oh, there are a few weirdos in the room. Did anyone choose multiply by the reciprocal? Good. Did anyone simply cheat by looking at their neighbor and not do any work? Couple. Okay. So I'm going to use multiplication by the reciprocal. So I'm going to keep the first fraction, and I'm going to change to multiplication by the reciprocal. Now, there is a note. I want to make a note. Note. And if you have your paper, you should make a note right now. You can't cross-reduce division. I'm going to put 3 exclamation points because I want it to be loud. Kind of like Pinky Tuscadero getting angry at her brother for stealing the last cupcake. I want it to be loud. You can't cross-reduce division. There are people who try and do something bizarre like this. Okay? And I want you to be aware that when I taught you cross-reduction, the purpose was multiplying the numerators and multiplying the denominators is not affected by swapping the numerators. And that's the reason why we say cross-reduction works. But it doesn't have the same impact on addition, subtraction, or division. So don't do it with any other operation than multiplication. Okay? So once we have changed it to multiplication by the reciprocal, then fill your boots. If you want to cross-reduce now, go ahead. It's multiplication. But when we look across, we can't, which means I multiply the numerators and multiply the denominators, and I get 15/16 as a final product. So therefore, the division answer is 15/16. In the second question, B, what would you do for B, first step? Of course, as the elf at the back of the room will tell you, the first step is to change them to improper, and then keep the first fraction, change the multiplication, and use the reciprocal of the second. Okay? So if you are working on a test and you see a mixed fraction, just change it to improper right away. You know you can't be wrong. That's good. Unless you're doing modeling, like a certain elf did at the back of the room. If you're modeling a mixed fraction times a mixed fraction, don't change it to improper. Cross reduce, 6 over 3 will reduce to 2 over 1. Multiply your numerators, multiply your denominators, you get your final answer of 10/17. And the last question, in question 9, says 12 divided by 3/4. Miss Hannah, of course, the first thing you should do before you do anything else is what? I couldn't hear you. Not yet. What do you do first in the last question? See. First thing. Anybody? Yes. Correct. You must consider whole numbers to be over 1. That's step 1. Once you get that, write it as a fraction, change to multiplication, and use the reciprocal of the second. Once you have that, of course, the first thing you're going to do before you multiply and get all gung-ho of getting the answer is you're going to look for what? Cross reduction is correct. Well done. 12 over 3 will reduce down to 4 over 1. You multiply the numerators, you get 16. You multiply the denominators, you get 1. Your final answer is simply 16. let's just, for argument's sake, check with a calculator. 12 divided by the decimal form of 3/4, which is decimal 75. Your answer is 16. Verified. Awesome. Mic drop. And your last question is redundant, so we're not going to bother. So, but you get the idea. There are certain things you do. It's not a big deal. It's pretty easy. Does anyone want me to go over the rest of the questions, or are we good? You want me to go over them real quick? I'm not going to talk, though. I'm just going to do them. You're going to follow along. You can press mute at home if you want, but here we go. Without words, here we go. This is exciting. Ta-da!